This is called an orthosonic sled, just to give it a name. I'll be using that in combination with two of these low-frequency Polk drivers. They can handle up to 50 watts RMS, and I mount them usually with a gasket, and then there's a faceplate of wood that it gets mounted to, and on the other side we have an oval port like that. So putting them together, I have two over here facing each other, and they're wired anti-parallel so that when this speaker advances, the other one is retracting, and you have both diaphragms moving in unison like that, creating a very long wave. At 60 cycles per second on my new wave generator, and at around 18.7 degrees centigrade, we have about a 5.7 meter wavelength. And that's very long compared to the 20 centimeter distance between these two faceplates. Now, I have a scale here. Currently it reads about negative 109 grams. That's to tare the weight of the orthosonic sled, which happens to be that. And I'm going to bring this in and set it on the scale here. So there's the sled on the scale. I'd like it not to touch either faceplate if possible. And then I'm going to put a little tape there, because otherwise it tends to vibrate. These low-frequency vibrations, things don't sit still. In fact, this is my second time taping this experiment, because the first time it did fall off the scale pan 2 times, and I didn't like it. Okay, so now we see that that tears to about 0 grams right on the nose. We have a power meter back here. These two speakers are both 8 ohms each. They're wired anti-parallel, so I set the power meter setting to 4 ohms total power, and we're on the 200 watt setting. We're going to go up to 1 watt, 5 watts, and 10 watts on that scale. And I'll tell you when we get there. But we'll look at the weight. So right now the apparent mass is 0.0 grams. The power is at 0. Let's go up to 1 watt. So I'm going to turn this up a little bit, 60 cycles per second. And that's 1 watt. And down here we now have a negative 0.6 or 7 grams apparent decrease in mass. Go up to 5 watts. That's about 5, and you can see the LED lit for 5. And here we now have minus 2.5 grams. And if I go up to 10 watts, total power, it's a little more than 10 watts. We now have negative 4.4 or so grams. And if I now bring that power down back to 0, we see that that goes back to 0. So I'm going to keep it on here and turn the power up to 10 watts again. That's 1, 5, and a little more than 10 watts. And there you see it on the meter. And now I'm going to just come down in power. Okay, so a little vibration caused touching there. If I straighten that out, we're right back to 0 grams. Okay, now, with that said, I'm going to untape this a second and invert the sled so that it now comes in upside down on the scale pan, and the sonic flow will be in a channel underneath the sled instead of on top of it. Okay, so we're 0.0 grams, 0 watts. We're going to turn the power up to 1 watt. And now we have a 0.8 increase in apparent mass. And I'll go to 5 watts. And we have about a 3 gram increase in apparent mass. It's pulling downward. And go to 10. A little more than 10, and we have a 6.5. And if I lower the power, we're back to 0 and 0 watts. So we see that in the open air, essentially, that a AC flow can generate lift and the inverse of lift, depending on which side of an open plank the sonic flow is on.